Hello. Purpose of this video is to explore the graphs of absolute value function equations. So we have an equation with two variables which, as we've learned, has infinite solutions. And what this video is designed to do is to demonstrate the kind of analysis that will make you successful in future levels of mathematics. So, in other words, there's a type of thinking that I'm trying to sell here. This is not something that's generally applied to real life, but trust me when I tell you that down the road, the skills you're going to learn here are going to serve you very well. So here's the thing. I know that there's going to be an absolute value function, and from what we learned from Walk It Home, this function is going to be 3 to the left of the origin, because to get home it had to go plus 3. So the absolute value graph used to be over here, and to get home it had to go plus 3. So anyway, plus 3 is means that the absolute value is going to be above the x-axis, because we had to go up 3 or add 3 to all the y values. So we have a normal absolute value thing would be on the x-axis, and we're going to add 3 to all those. It's going to shift up. So here's how I document my thinking. Here's how I document my analysis. I take 3 clues from the equation itself. Plus 3 says that the graph from the origin would have to shift left 3. From the origin would have to shift up 3. The rays representing the absolute value are going to have a slope of 1, because the a value is 1 there. It's not shown. Now, before I actually make the graph, it's important to reflect on what is the graph going to look like. So what I suggest and would really like to see is that you draw a quick sketch. No ruler, no scale, no details. Just give me a glimpse of what you expect to see when you produce a quality graph. Now we're going to take the details. From the origin, we want to go left 3. So this little vertical mark here shows me what left 3 is going to be like. So we're taking the absolute value, moving it left 3, and then I make a quick horizontal mark at y equals 3, and there is the new origin. So there used to be an absolute value graph right here. It went left 3, it went up 3, and now all I have to do is draw, after I label that new vertex, that new origin, I'm going to draw a line or a ray with a slope of 1 in this direction. I'll show you how I got that, and then a slope of -1 in the other direction. Then I'm going to label my points, and this is how I knew that my line was drawn correctly, because if the slope is 1, then we have to have a change in y of 1 for every change in 1x. So that continues on, and that's how I knew we crossed at 0, 6. Now to analyze what I've done with my graph, essentially I've learned that this absolute value is representing 2 rays, the increasing one, whose y-intercept is 6, as we learned, and whose slope is 1. And then there's a decreasing line whose y-intercept, well, if I was to continue down in this direction, seems to be the origin. So the y-intercept is 0, and the slope is -1, representing this equation. In other words, this absolute value function is the composite of 2 different functions, one with all the positive stuff, and one with all the negative stuff. In other words, one where we remove absolute values and just add up what we see, and the other where we remove absolute values and take the opposite of what's inside the absolute values to account for that, and it gives us our 2 equations. So algebraically we can see the 2 equations just by removing absolute values, and geometrically we can see the 2 equations just by shifting lines from the origin. Now the other way that we can check, of course, is to use a point on the graph and verify that the point -4, 4 is in fact a solution to the equation. So doing, substitute. When I put -4 in for x, I should expect to get 4 out for y, which I do, and that is some confirmation along with all the other analysis. Clearly this is good quality work. Quickly now for the rest, we're going to do the analysis. So I'm imagining an absolute value graph that's shifted to the right 2, because it has to go back home, and then it's shifted up 4 and has a slope of 1 or -1. In other words, I'm going to get an absolute value graph that looks something like this. It'll be the first quadrant. I go over 2, I go up 4, I put a little origin there, really lightly sketch that in, and then I draw a ray of -1 slope and a ray of +1 slope. Label a couple of points to verify that the slope is 1 or -1. Of course, we can identify 2 lines here, one of them with a -1 slope and a 6 y-intercept. I know that from counting over. And the other has a positive slope and a 2 y-intercept. Once again, I count over 1, down 1, over 1, down 1, and there I am, extended to y equals 2. So these are the 2 lines. Algebraically, I can do that by removing the absolute value and just adding what I see, removing the absolute value and negating what's inside of it, and then adding what I see, and you can see that's consistent with what I saw on the graph. Again, we can check our work by substituting any of these solutions. They should be solutions to this equation. But that's been demonstrated for you, so we'll move on. Thanks for watching. Have a great day.